Hello, we are Team 6 and we're going to talk about the element of the selenium.
So the electronic configuration of groups 16 consists of NS2 and P4, which which means they have 6 electrons in their valence shell. So the valence shell of group 16 has 2 electrons in the subshell and 4 in the p subshell. Of the 4 electrons in the p subshell are 2 paired and 2 are unpaired. So one is short and the other is having the same configuration as the nearest noble gas.
Okay, the place found in the periodic table means that in the group 16 is the third to last column on the periodic table. It is also known as the oxygen family or the chalcogens. The elements in the group 16 are also known as ore forming elements because many metal ores are found in the Earth's crust as sulfides and oxides. The elements also have 6 electrons in their valence shell, giving them 2 electron shorts of a full outer shell. The most common oxidation states of the elements of the group 16 are -2, +2, +4, and +6. The atomic and ionic radius of the elements in group 16 increases as you move from oxygen to polonium. The elements in group 16 react with hydrogen to form hydrates of these sorts, and the elements are immediately related to life.
Okay, so some characteristics of this group is that the elements in this group are also known as chalcogens, that are oxygen, sulfur, selenium, tellurium, and polonium, and also livermorium, which their characteristics are that the group includes non-metal, metalloids, and metals. For example, the oxygen and sulfur are non-metals and selenium is a metalloid. And tellurium and polonium are metals. The reactivity. The elements are somewhat chemical unstable and more likely to react with other elements. And their bonding. The elements form covalent bonds with non-metals and ionic bonds with metals.
The physical properties. Their state is like oxygen is a gas at room temperature, where other elements are solids. The allotropes in elements in the group exhibit allotropy, meaning that they can exist in multiple forms. They have atomic and ionic radius increase down the group as atomic number increases, and melting point and boiling points, meaning that increase down the group as the atomic size increases. And their chemical properties is that they are hydrates because they react with hydrogen to form hydrates, which are poisonous gases with unpleasant smells. The dioxide and trioxides, meaning that react with oxygen to form acidic compounds. They are halides from a variety of halides. They are oxygen states. Most common oxygen states, as I mentioned before, are common like -2, +4, and +6. And they have tendency to combine each other, meaning that they combine with other metals to form common ores in the Earth's crust.
Well, now I'm going to tell you about some interesting facts about the collagens. First is that all naturally occurring collagens like oxygen, sulfur, selenium, tellurium play roles in biological functions, either as nutrients or toxins. For instance, sulfur is essential in amino acids and proteins, while selenium is a nutrient but can be toxic in higher amounts. Chalcogen compounds can have significant environmental impacts. Sulfur dioxide contributes to acid rain, but chalcogens are also used in technologies like solar panels and thermoelectric materials. Now, oxygen was named by Anthony Laurent Lavoisier in 1777. Polonium was discovered by Marie Curie in 1898 and named after her native country, Poland. Tellurium was named after the Latin word for earth, Tellus. And last is that sulfur is second only to carbon in its ability to catenate, forming chains of sulfur atoms. Other heavier chalcogens show this property to a lesser extent, which polonium showing no such tendency. And if you wonder, catenation is the ability of atoms of the same element to link together in a series, forming chains or rings.